This video is about computer science careers in the post-ChatGPT age. Recently, auto-coding tools such as GitHub Copilot and ChatGPT have been making headlines about their impressive capabilities. Many YouTubers have been making videos about how allegedly these auto-coders will replace computer programmers. This has led to many people getting discouraged and becoming doomers. I have heard that students have been dropping out of computer science courses in a real or imagined fear of ChatGPT. Is ChatGPT a threat to computer programmers? I want to provide an analysis of this intriguing question with a clear mind, no any sensationalism or alarmism. In this video, I will inform you 12 fields or 12 strategies about how to navigate a computer science career in the post-ChatGPT world. What careers will get automated away? That is our main question. Answer. The careers that will get automated away are the low-hanging fruits, the simple jobs or low-skill jobs. For example, front-end web development has a high chance of getting completely automated away within the next decade. The truth of the matter is that web development careers are already getting automated away. For example, Adobe Dreamweaver is a web development software that enables users build professional-looking websites with little to no coding experience. The software provides a visual design interface, a code editor, and responsible design tools that allow users to customize their website's appearance for desktop, tablets, and mobile devices. Wix is a cloud-based website builder that allows users to create professional-looking websites without any coding knowledge. The platform provides a drag-and-drop interface that makes it easy to create websites from scratch or use one of their hundreds of templates to get started. Amazon Honeycode enables businesses to quickly and easily build custom web and mobile applications without writing any code. This is a game changer in my opinion, as it can generate not only static HTML websites but also phone apps as well with custom programmed functionality. Now, before the appearance of such tools, if individuals, churches, and small businesses needed a client-facing website or a mobile app, they would simply hire a freelance web development to make that project for them. Typically a student or some other developer just wanting to make some easy side money. Now, these small non-technical companies can easily create their own website or mobile app using a click and drag graphical user interface. Other jobs that may get automated away are simple coding jobs, such as those involving writing unit tests for functions, writing comments and technical documentation, writing boilerplate code, and commonly implemented code like your standard sorting algorithms. These are tasks that GitHub Copilot or ChatGPT can already do. So we will see a lot of low-hanging jobs get automated away, which is bad news for interns or new people who want to break into the computer science world. The reduction of entry-level positions means that people will have to study and wait for a longer time to get up to the level of knowledge necessary to get a mid-level job. So it will become harder to break into the tech industry for freshers and raising the bar for the skills that you need for your first programming job. I predict that AI tools will wipe out coding boot camps within the next decade. They are paid private schools that teach people with no technical experience enough knowledge to get into an entry-level programming positions over a period of like half a year, for example. Mostly these coding bootcamps teach web development and mobile app development. However, when entry-level positions get wiped out and the creation of user interfaces gets automated by click and drag tools, then bootcamp graduates will be having an extremely hard time finding a job. So coding bootcamps will have to change their curriculum to focus on the following fields and strategies of computer science that will stay relevant in the post-AI world. And this is what I'm going to be talking about now. The first strategy about how you can stay relevant in the post-AI world is learn to use AI tools. In the post-AI age, when auto-coding tools will be widely used, the advantage will be with the software engineers who know how to use such tools to boost their productivity. For example, using autocoders to generate boilerplate code, unit tests for functions, and commonly implemented features like email validators, regular expressions. If you want to create any graphical user interface app, such as an Android app for example, there is a lot of boilerplate code that you need to write just to set up the GUI, the GUI. So you can use autocoding tools to write that for you. And then you can concentrate on the actual functionality of your application. Anything that you don't have to memorize, that you can just look up quickly. For example, searching Stack Overflow for an implementation of SHA-1 hash function in C. You can just ask the AI to generate that code for you. So it's basically a more advanced version of Stack Overflow. If you are on a new project with an unfamiliar language, framework, or API, auto-coding tools can help you with syntax, code structure, and best practices. The tool can also provide suggestions for libraries, frameworks, and APIs that you can use to speed up your development process, taking out the extra work that's required normally for researching what APIs or tools should you use. Additionally, auto-coding tools can help you with debugging and troubleshooting. If you're having an issue with your code, you can use the tool to identify potential problems and suggest solutions. The other thing that AI tools will be useful for is speed coding, writing code very, very fast. This can be useful if you are in a lead code contest, or just when you have to compete and submit a feature very quickly before the deadline. If you learn how to use these autocoder tools very well, then you can work faster than other programmers. You can also produce more code within a given period of time, such as 1 week. And that is how you can compete with other programmers, by becoming more productive than them. As I like to say, AI will not replace your job. Another programmer who will be using AI tools will replace your job. These tools will only work well in trained hands. So if you do decide to use autocoders, you should learn prompt engineering, the study of crafting input to the AI in the format that it expects, so that it can best understand your intentions and serve you better. Strategy number 2 about how to stay relevant in the post-AI world is to become an artificial intelligence / machine learning engineer. The saying is, if you can't beat them, join them. In the post-AI world, obviously the need for AI specialists will increase. If you learn artificial intelligence, you will be able to find a job. This field can be sliced up in 2 ways. There is the high-level AI development and the low-level AI development. The so-called high-level AI development entails using already trained large language models, such as ChatGPT, Alpaca, or Vicuña, to build AI-enabled applications. OpenAI has its own API, and you can use it to build chatbots, autocoders, general-purpose text processing applications, and even video game AIs. For high-level AI development, you need to have knowledge of LLMs, LangChain, Pinecone, and embeddings. It's using several APIs in Python scripts, but it doesn't require in-depth knowledge of mathematics and machine learning methods. On the other hand, the so-called low-level AI development focuses on building those APIs and training large language models and neural networks from scratch. This is where you need to know the mathematical and statistical concepts. You need to know the data mining algorithms that are built upon this firm foundation of mathematical knowledge. Jesus Christ taught that we should build our house on the rock, not on the sand, not on the beach. So, low-level AI development is an example of such a field that requires a firm mathematical foundation. The mathematics is the rock that you will build your house on top of. And you can learn the math from YouTube like Khan Academy. You also need to know NumPy, SciPy, PyTorch, and TensorFlow. I would say that both high-level as well as low-level AI development, the coding requirements are not particularly hard, as most of the code is written in Python, which is not that hard to learn. Usually people find difficulties with the mathematics part, and that's only for low-level AI development if you want to become a machine learning engineer. Okay. Strategy number 3 about how to stay relevant in the post-AI world is to go high level. What do I mean by that? So, if AI can write the code for you, then more emphasis will be placed on high-level design of software applications. This entails knowledge of how software systems are designed. You need to have a bird's eye view of the entire application's architecture, which means how the application is built with respect to how different modules of the application fit and work together. You can no longer limit yourself to just a few several files. You need to have that big picture of the application. Where is the input coming from? How does the application process that data? How is that data getting stored? Which modules perform which actions? You need to know how to design a complex software system. For example, how would a Skype clone be organized? Would the individual Skype clients connect to each other directly? Or would they connect to a centralized server that would then be routing calls between the individual clients? How would such a system scale to millions of users? How would a CCTV security camera system work? If you have data coming in from dozens of webcams observing different parts of the building, how would you handle that? Those are some of the questions that a system architect needs to answer. And you also need to know how the overall design is architected, and then you also need to know the design patterns, such as data-oriented design or object-oriented design. What is a factory, an adapter, a visitor in terms of software design? Another way that you can get the advantage over other programmers by leveraging the knowledge of high-level programming concepts is by learning data structures and algorithms. In a world where the code implementation matters less, then more emphasis will be placed on data structure and algorithm design and complexity analysis. Now, in the early 2000s, the whiteboard interview was a very common practice in big tech companies. There you had to go to the whiteboard and solve algorithm-type problems. Around 2010 or so, companies started phasing out the whiteboard interview and bringing in the coding interview instead. They thought that the whiteboard interview was a waste of time and the poor assessments of the candidates' practical coding skills. They used platforms such as HackerRank to create coding challenges that the programmer had to complete. Now, with the widespread use of auto-coding tools, anyone can easily write code to reverse a linked list. So now you will be asked to demonstrate a deep knowledge and understanding by writing the algorithm to reverse a linked list on the whiteboard and explain it to the interviewer. So expect companies to bring back the whiteboard interviews in the 2020s. This has the effect of lead code or HackerRank becoming useless for judging the abilities of a programmer. They are still good for personal practice, but companies will no longer be using them for conducting coding interviews. Having knowledge of fields such as discrete maths, graph theory, state machines, and theory of computation also wouldn't hurt. We'll eventually get to a point where only a handful of software engineers will be responsible for the design and the algorithms, and then they will implement it using auto-coding tools. Strategy number 4 is to go low level. The low-hanging fruits jobs will get automated away, so you need to know more specialized knowledge. Become a domain expert. Anyone can use AI to write code, but do you understand the code that you're writing? Can you explain what the code is doing at the low level? Do you know the details of the programming language? Do you know the pitfalls, trips, and traps that can lead to silent bugs or undefined behaviors that not even the autocoder will be able to find and fix for you? Do you know how integers and floating point numbers are represented in the binary, and what that implies for the range and spread of values that these data types can hold? If you are using a compiled programming language such as C++, Go, or Rust, do you know what kinds of assembly code will the high-level code be compiled into? Can you take a look at some C code and immediately see the equivalent assembly code in your head? Such knowledge is very important for writing performance-critical code and also writing very secure code that cannot be hacked. Knowing the low-level details of the programming language, compiler, and operating systems can open the door to so-called low-level programming jobs in fields such as Linux systems programming, drivers programming, networked applications development, embedded systems compiler development, OS development, and kernel modules development. Writing applications for constrained systems, for example, handheld gaming consoles such as the Game Boy Advance. Such fields require domain experts and probably will not get automated away in the foreseeable future. I personally don't like the term low level as it implies unsophisticated. So I would like the term deep level. So a programmer who has a deep understanding of the code is unlikely to ever get replaced by an autocoder. And even if he loses his job at one company, his deep level of knowledge can get him a job at another company. And I'm just fascinated at how the programming language works, or how the compiler works, the file descriptor system calls and all that, is the spirit of open source Unix hackers, which requires personal enthusiasm and curiosity, which is something that the AI doesn't have. So if you do decide to go down this path of becoming a deep level programming expert, I can recommend this book. This is the 3rd edition. Computer Systems: A Programmer's Perspective by Randall E. Bryant and David R. O'Halloran. Let me just read the introduction to this book, the preface. This book, known as Computer Systems: A Programmer's Perspective, is for computer scientists, computer engineers, and others who want to be able to write better programs by learning what is going on under the hood of a computer system. Our aim is to explain the enduring concepts underlying all computer systems and to show you the concrete ways that these ideas affect the correctness, performance, and utility of your application programs. If you study and learn the concepts in this book, you will be on your way to becoming the rare power programmer who knows how things work and how to fix them when they break. You will be able to write programs that make better use of the capabilities provided by the operating system and systems software that operate correctly across a wide range of operating conditions and runtime parameters, that run faster and that avoid the flaws that made programs vulnerable to cyber attack. You will be prepared to delve deeper into advanced topics such as compilers, computer architecture, operating systems, embedded systems, networking, and cybersecurity. This is a really great book. I recommend it. And indeed, it has been my mission for the past several years, just on and off, studying this book, going through the book cover to cover and doing all the exercises to make sure that I completely understand this. Okay, that was number 4. Strategy number 5, about how to stay relevant in the post-AI age, is working with legacy code. Consider ChatGPT as just another tool that software engineers can use. Some companies use the latest and greatest tools, and others just don't. There will always be companies who are resistant at using new AI tools according to various reasons, maybe convoluted bureaucratic reasons or technical reasons. Consider the use of the Rust programming language. It was first published in 2015, yet in the 2020s, although several large companies like Mozilla have been using it in various projects, it is still considered as the repertoire of startups, companies that are working on new projects. There are still many companies that are using C++, either because they already have a large C++ code base that would be inordinate to rewrite in another language, or simply because their engineers don't know Rust or are too busy to learn it. Something similar will happen with ChatGPT, that only the top third or even fourth of companies who are forward thinkers will use it, and the rest will not use it. One of the reasons why some companies don't use ChatGPT is because it has been trained on open source code from GitHub. I don't know how licensing works, nor does it make sense to me, but I have heard that allegedly some companies that are developing proprietary code would object to using snippets from open source codes, since that could potentially make the proprietary code open source too. But don't quote me on that, because that's not within my level of expertise. Another reason is that when you use ChatGPT, your code gets sent to OpenAI's server, and theoretically whoever is managing that server can read your code. While that can be mitigated by using a locally installed large language model such as Vicuña, the majority of people just won't go that extra mile. Just as in the 2020s, there are still companies that use old programming languages such as COBOL and ALGOL. There will always be companies that write code the old-fashioned way. And there is a shortage of programmers who specialize in programming languages such as COBOL in the 2020s, which means that companies with legacy code offer high salaries. There are a lot of already built applications that need to be maintained. Some of them were originally created 20 years ago or even half a century ago. We can even consider lots of applications written in C for Unix systems as a kind of legacy code too. So basically a lot of companies have legacy code that needs to be maintained, and that's a job that doesn't require new development of code. So if you are interested in this field, I can recommend the book Working Effectively with Legacy Code by Michael Feathers and Robert Martin. I don't have the book with me, but I just recommend you. Strategy number 6 about how to stay relevant in the post-AI world is a systems or a network administrator. ChatGPT stands for Generative Pre-trained Transformer. But I think that a more fitting definition for that algorithm would be general purpose text. Chat general purpose text. It's a general purpose AI whose input and output is text. The reason why coding is considered susceptible to automation is because the computer code is a text. The job of a systems administrator involves more than just writing code, although they often do write shell scripts. Systems administrators are responsible for ensuring the smooth operation of an organization's IT infrastructure, including servers, networks, and applications. They install and configure hardware and software, monitor system performance, troubleshoot issues when they arise, and maintain security and backups. Additionally, they often provide technical support to end users and collaborate with other IT professionals to implement new solutions and improve existing systems. This is a job that requires more moving parts and more human interaction than just writing code all day. The job of a systems administrator or a network administrator lays on a firm foundation of technical skills, but the duties that the administrator performs are very varied, unpredictable, and non-deterministic. The job of a systems administrator involves a wide range of tasks and responsibilities that require human judgment and decision making, making it less susceptible to being fully automated away by AI. So, these professionals need to have a deep understanding of an organization's IT infrastructure, including hardware, software, and network architecture. They must also be able to troubleshoot complex issues and think critically to find solutions. Additionally, they need to work closely with other IT professionals and end users, requiring strong communication and collaboration skills. Certain tedious tasks such as parsing log files could be automated. You could give ChatGPT a log file and ask it to return you lines containing only a certain host name or IP address. The expertise and problem-solving skills of a systems administrator are difficult to replicate with AI, making this profession less likely to be fully automated away in the near future. Strategy number 7 is becoming an entrepreneur. Make your own startup company. In the post-AI age, software developers can thrive by becoming entrepreneurs and creating their own companies. With their technical skills and knowledge, they can identify gaps in the market and develop innovative solutions to meet the needs of businesses and consumers. To achieve this, software developers can leverage ChatGPT's natural language processing capabilities to gain insights into various industries and identify potential business opportunities. It can be used to automate tasks such as customer service, content creation, social media management, sending email newsletters, freeing up time to focus on building and growing your business. You can query it to provide instant and accurate answers to a wide range of business questions, from marketing and sales strategies to financial planning and budgeting. So you save time and money by reducing the need to hire additional employees or consultants. Even non-software entrepreneurs can take advantage of AI tools by creating their own website or mobile app to connect with customers, as I've already said. AI tools will also make software startups more compatible with big tech companies. A good example of this is indie gaming. A team of maybe less than 20 people can use AI tools for generating realistic images, sounds, 3D models, and code. and make much bigger in size projects that were only available to big tech companies in the pre-AI age. Strategy number 8 is cybersecurity hacking. In the post-AI world, you have this phenomenon where a lot of amateurs or non-technically minded people will be using auto-coding tools for making their own applications for personal or commercial purposes. Typically, these people will learn just enough coding necessary to slap an application together so that it works. They will not take the time to understand how the code works. They will just copy and paste AI-generated chunks of code into an IDE and build the app. Or they will use a point-and-click interface like Wix and not touch the code at all. ChatGPT and GitHub Copilot can generate code, yes, but I didn't say that it was good code. There have been instances where it generates a flawed or buggy code that is not so robust. And the increased use of AI tools will create more applications that work, but just barely. These applications would have a lot of bugs and vulnerabilities in them, not validating inputs against SQL injection attacks, for example. It is a security hacker's job to find bugs in applications and exploit these bugs. So the increased use of insecure codes will increase the demand for cybersecurity professions, both offensive and defensive. In the near future, there will be a large demand for cybersecurity consultants. You would go to amateurs who create their app using the no-code auto-coding tools, and you would take a look at their code and fix any security vulnerabilities and make the code more robust against bugs. The constantly evolving nature of cybersecurity threats makes it unlikely for hackers to be fully automated by AI tools. Cybersecurity requires a deep understanding of complex systems and networks, as well as creative problem-solving skills that are difficult to replicate with AI. While automation can assist in certain tasks, the expertise and human judgment of cybersecurity experts are essential to identify and respond to new and evolving threats. Strategy number 9 is going into physics or mathematics programming, scientific computation. Many people do not see physicists and mathematicians as coders, but the truth is that these two groups of scientists frequently use coding to solve their problems. Let us not forget that computers and programming languages were invented first and foremost for solving mathematical and physical problems. In fact, many physicists had made huge contributions to computer science. And actually, one of the best programmers who I know at Intel was actually a former physicist. There are lots of jobs for physicists and mathematicians in national laboratories. Typically, you would solve an equation or formula and then write a computer program implementing that solution across a distributed network of supercomputers. Mathematicians solve the problem by integrating, distributing, taking the derivative, etc. But the computers are used for number crunching. Angular JS coders, for example, are more susceptible to being replaced by ChatGPT because coding is the only thing that they bring to the table, whereas the skills of mathematicians and physicists are indispensable. And more likely, scientists would find autocoders as a welcome tool for code generation when they are too busy to implement or learn coding on their own. Relevant fields are scientific computation, data analysis, bioinformatics, modeling and simulations. Strategy number 10, about how to stay relevant in the post-AI world, is going into hardware engineering or electronics engineering. Since AI is a software construct that works on general purpose text files, working with the hardware is a good way to ensure job stability for yourself, as hardware and electronics engineering is unlikely to be automated away anytime soon. Hardware development can also be subdivided into two parts. I call them high-level hardware development and low, more rather deep level hardware development. High-level hardware development can be considered building the computer out of pre-made parts. For example, repairing computers, building custom computers, anything involving networks and various devices. This is the kind of job that people typically imagine are IT nerds. Deep-level hardware development is concerned with developing the individual components of the computer, such as the CPU and the random access memory and various storage devices. This requires much more deep knowledge, even more so than software development. This is even intertwined with electronics and electrical engineering, requiring you to know such concepts as logic gates, digital electronics, and analog electronics. There is a high barrier of entry as well. Whereas software developers can get by with self-taught curriculum, computer electronics engineers have to go through the full university curriculum in order to have the knowledge that would get them hired at a hardware company such as Intel Corporation. Typically, most people who work as hardware engineers at Intel have master's and PhD degrees. It takes a lot of work and studying in order to get to that level, but the satisfaction is that AI tools will be unable to replace an engineer at such level. Strategy number 11 is robotics, mechatronics engineering. Any job that requires tinkering with physical devices is unlikely to be automated away in the near future. In fact, the demand of robotics engineers will actually increase in the post-AI world. There will be demand for people who know how to integrate the software with the hardware. Right now, robotics is not that advanced compared to AI software, and it is still a developing field. Mechatronics is the discipline of building mechas. Mechas are 20 feet tall Japanese robots. It is a field combining mechanics and electronics, hence the name Mechatronics. Both of these fields on their own require in-depth knowledge and physical tinkering. It is not virtual as is software development, and hence less susceptible to being automated. Designing robots is hard because of multiple reasons. Software engineering seems both easy to learn and work in compared to robotics. You can learn programming via YouTube lectures completely for free. But compared to software engineering, robotics and mechatronics have 1,000 times fewer materials to learn on the internet. Therefore, this is one of the very few fields that you have to go to university in order to study it. You can learn programming, mathematics or physics online, but mechatronics you have to learn only in a laboratory setting with an experienced engineer as a mentor. Strategy number 12, about how to stay relevant in the post-AI world, is becoming a project manager. A software project manager is responsible for overseeing all aspects of a software project, from planning and budgeting to implementation and delivery. They must ensure that the project meets its objectives and is completed on time and within budget. This involves working closely with the developers, designers, and other stakeholders to coordinate tasks, resolve issues, and manage resources. A project manager is unlikely to be replaced by ChatGPT due to the complex and nuanced nature of their job. Project management involves a wide range of skills, including communication, leadership, problem solving, and decision making that require human judgment and experience. While ChatGPT can assist with certain tasks, such as scheduling and resource allocation, it cannot fully replicate the human skills and expertise required for effective project management. Additionally, project managers often have to navigate unpredictable situations and make decisions in real time, which requires the ability to adapt and respond to changing circumstances. It is a job that entails organization and complexity management. Tools can be used, but ultimately it is up to the human to decide in which direction to steer the ship. So that was 12 different strategies for computer science careers in the post-ChatGPT age. If you found this video useful, please hit a like or subscribe, and also add a comment down below to give me your feedback. It is very useful for me. And also check out my channel, see if you find any other videos useful. Thank you.